As many of you already know, Comet 3 I/ATLAS has officially passed Mars and is now rapidly advancing toward the Sun. This is the most intense phase of its interstellar journey. But this comet is highly atypical. It's already spewing water far sooner than it should be, and its coma is packed with carbon dioxide, making it the strangest comet of the year. Clearly, this visitor is not from around here. With perihelion rapidly approaching, astronomers have locked their telescopes onto it, waiting to see what happens as sunlight and radiation increase the heat. What I'm going to attempt to do in today's video is explain these new findings, why they matter, and what this wild space wanderer might do next. The whole 3 I/ATLAS saga began back in July of 2025, when astronomers in Hawaii, using the ATLAS survey, spotted a small object moving too fast to be gravitationally bound to our Sun. With a quick look at its hyperbolic orbit, we confirmed our third interstellar visitor, following the cosmic celebrities Oumuamua in 2017 and Borisov in 2019. Fast forward to early October. It crossed the orbital lane of Mars, and Europe's ExoMars Trace Gas Orbiter managed to capture a stunning remote photograph of it. There was seemingly no tail, just a bright, dense coma. This suggested that the comet was not following the typical grow a tail and brighten scenario. Meanwhile, ground-based telescopes and the James Webb Space Telescope teamed up for a spectroscopic deep dive. They found that 3 I/ATLAS was blasting out approximately 40 kilograms of water vapor per second, like an oversized space humidifier, while still 2.9 AU away from the Sun. That's a lot of enthusiasm coming way too early. Furthermore, the carbon dioxide to water ratio was completely flipped compared to most comets we know. Instead of water taking the lead, 3 I/ATLAS seemed to be powered by carbon dioxide, essentially the cosmic Fizzy comet. Polarimetric observations backed this up, showing that its dust scattered light in a way that suggests superfine grains or downright weird chemistry. And get this, older data from the Transiting Exoplanet Survey satellite showed it was already active when 6 astronomical units away from the Sun. That's so far out that most comets are still in hibernation mode, refusing to even acknowledge the Sun's existence. This kind of early activity is incredibly rare. It tells us that 3 I/ATLAS formed somewhere much colder and chemically much more unusual than our local neighborhood. It hails from an entirely different star system, one with its own rules, its own atmosphere, and apparently its own comet slushy recipe. This is what makes scientists both highly excited and perhaps slightly confused. Typically, water ice doesn't begin to sublimate until a comet gets closer than 3 astronomical units, which is why most comets snooze until they reach the inner solar system. But not 3 I/ATLAS. It decided to wake up early and cause trouble. The current strongest theory suggests that super volatile chemicals like carbon dioxide or carbon monoxide were hidden just below the surface. These are so sensitive that the slight warmth of deep space was enough to make them burst. This pressure might have cracked the shell, allowing gas, and eventually water, to escape far ahead of schedule. Another possibility is that its nucleus is a crumbling mess, porous or fractured enough for sunlight to penetrate deeper and heat the contents faster. Whatever the explanation, one thing is clear. 3 I/ATLAS offers us a rare peek into what comets in other star systems are made of, and it's wildly different from what we are used to seeing around here. A carbon dioxide-heavy comet, like 3 I/ATLAS, points to one big thing. This traveler was born in the freezing cold outer suburbs of a faraway protoplanetary disk. not the warmer, coffee-drinking region where our own comets typically form. Its interstellar orbit also supports this, making it the cosmic equivalent of a tourist with a very foreign passport. Even its polarization, the fancy term for how its dust scatters polarized light, refuses to match the patterns seen in local comets. This means the dust grains could be differently structured, sized, or even made of minerals we barely see here. Since dust grains are essentially carrying the chemical selfie of their home system, scientists can truly piece together what kind of environment shaped it. Yes, there are always the bold theories, hats off to Avi Loeb, that maybe it's aliens. But in this case, everything points to a completely natural origin. Just an extremely volatile, chemically unique snowball forged around a distant star. Sorry, sci-fi fans, for now. While Oumuamua and Borisov are already in the Hall of Fame, 3I/ATLAS is only the third confirmed interstellar visitor. This makes these objects rare VIP guests to the solar system party. Each one helps us learn how planets and comets form, not just in our little neighborhood, but throughout the galaxy. Now for the real suspense. On October 29th, 3I/ATLAS is approaching its closest encounter with the Sun at 0.53 astronomical units. This is literally the hot seat moment. Astronomers are readying their popcorn because there are three outcomes on the table. 1. The Great Eruption. It suddenly throws a flashy cosmic tantrum and grows a dramatic tail. 2. Fragmentation. It cracks like an overheated cookie. 3. Smooth survival. It cruises by the Sun casually, as if it's no big deal. This is the least likely, but hey, comets love surprises. No matter what happens after perihelion, this will be crucial. That's when we'll grab the best data and hopefully the juiciest secrets of this interstellar intruder. CUIS, the European spacecraft, is currently hanging out on the far side of the Sun, perfectly positioned to watch what happens after it rounds perihelion. The catch is, it will be using its slower backup antenna, so the scientific updates will come in a fashionably late delay sometime in early 2026. Here at home, the James Webb Space Telescope, Hubble, and a whole army of ground-based telescopes will be watching the show in near real time, tracking every change in the coma, every chemical shift in the spectrum, and every dramatic outburst if 3I/ATLAS decides to make one. If it survives this fiery close pass with the Sun, it should reappear in our sky in early December, gliding past Earth at a comfortable distance of 270 million kilometers. No need to panic. That's basically the other side of town on a galactic map. This return gives researchers a perfect before and after comparison. How does the Sun's heat transform material that formed around a completely different star? It's the kind of experiment you can't run even in the coolest labs. And the stakes are bigger than this singular visitor. With 3I/ATLAS joining Oumuamua and Borisov on the interstellar scoreboard, we start piecing together how debris travels between star systems and how planet formation might differ across the galaxy. These cosmic hitchhikers can carry clues about how worlds are born, evolve, and sometimes toss their leftovers our way. Plus, every interstellar detection helps scientists refine their early warning systems. This means the next time a mysterious object plunges into our solar system, we'll be ready to grab our telescopes faster. Every time one of these interstellar visitors swings through our neighborhood, we learn a little more about how many of them are out there, what they're made of, and how they react when the Sun turns up the heat. As our detection tech continues to improve, we might soon be ready to closely examine future cosmic travelers. Maybe even send a dedicated spacecraft to chase one for a proper meet and greet. 3I/ATLAS is setting itself apart from every comet we've seen, from its weird chemistry to its very early activation. It's like a walking, or rather flying, hint from a completely different star system. And the upcoming moment at perihelion is not just a dramatic plot point. The results could change how we research interstellar objects for years to come. Before we wrap up this cosmic journey, I want to thank you for being part of it. Every comet, every star, every strange visitor reminds us how much more there is to explore. If you've enjoyed traveling through space with me today, your support really matters. So don't forget to subscribe and help this channel keep exploring the universe. Now I'm curious, what do you want to see next? Should we chase down another interstellar object? Or dive deep into a black hole's secrets? Let me know in the comments. And until next time, keep looking up.